Here we're going to calculate the corresponding confidence interval on the population proportion. Now when we say corresponding, what we mean is that it's corresponding to a hypothesis test. We don't always have to do this, but in this case we are, just to see if they're in agreement. We're going to assume that alpha is 0.05. So first thing we've got to do is calculate the corresponding confidence level. And if it's a two-tailed test, it's going to be 1 minus alpha. So in this case, 1 minus alpha is 1 minus 0.05, which would be 95%. Now, how do I know that this is a two-tailed test? All I have to do is look at the alternate hypothesis. Notice it has a not equal to sign. That means in the alternate, we're saying that the proportion could be greater than 0.75 or it could be less. Those are two tails of the distribution. So the confidence interval formula for P is P hat plus or minus Z times radical P hat Q hat over N. If we plug in all the values and then work it out, we get an interval that basically goes from 0.69 up to 0.91. That is 69% up to 91%. And notice that the value we substituted in for Z in our formula is 1.96. That comes from the table in the back of the book. So we are 95% confident that the true value of P, the population proportion, is contained in the interval that we calculated. This interval supports the conclusion we made in the hypothesis test, which, if you remember, was that we decided to fail to reject the null hypothesis. And if you'll notice, the claimed value for P, which is 0.75, is actually contained in our confidence interval.